In the last video, I got the core of my PCB version 0.10 up and running. Since then, I have populated the rest of the system, and I thought I'd provide an update maybe on some of the things that are here, and then maybe some of the challenges or things that I need to work out yet as I've put the rest of the system together. On the screen, I do have pulled up just a page where I'm capturing some of this, I guess, as I go. And so this is on a blog post on my page, but I was going to just jump down and maybe talk about some of the issues and modifications I've made to this. One of the first issues is when I turn the system on, my reset card is not holding the reset low when power is applied to the PCB. Now if I hit the reset button, it works fine, and I can watch this LED and it holds it low for a moment based on how I have this potentiometer set. And then it goes ahead and continues with the boot. For some reason, when I connect here to the PCB, that hold on initial power up isn't working. So I just disconnected power to the PCB, and when I turn it on, you'll see it holds it there on a low just for a little bit before it actually lets the rest of the system turn on. And I can adjust that, so I can come in here and let's see, I'll just turn this a bit. So now when I turn on the system, it holds it low for a longer period. And so I can adjust that as necessary, but for some reason, when this is connected to the rest of my system, it is not doing that low. So I've got to figure out what's going on there. That does not occur with the breadboard system, and I also pulled grabbed the card that I was using on the breadboard and tried it here, and I get the same results. So it's something when I apply power to this, that circuit I have designed to hold that reset low is not working. Now it's interesting, this whole system now at this point is taking less power than the breadboard version. So I'm looking at my benchtop power supply right now, and I'm at 714 milliamps to power this as it sits right here. I do have these LEDs disconnected just because there isn't a need for them. I'm running at high speed at this point. So that's something that for now, at least, I just have to hit the reset and actually use that to do the turn on of the system. I shouldn't have to do that manually, but I'll for now do that until I can figure out what's going on there. So that's one of the issues I've encountered. And that's the first thing that's probably noticeable here. The second thing that's maybe noticeable is my temp and time coming from my real-time clock are not coming back with the right data. And I think that's just a timing issue. And the reason I say that is if you look at the screen, when I do a reset, I'm doing a couple of things. I'm writing, all this information to the nano, which gets to this OLED, and that information is all coming through fine. And the way I'm writing that to the nano is from this VIA. So this is my VIA. That's working. This 8-character 7-segment LED display is working fine. And also the SD card reader is working fine. As you can see on the screen, it's reading that data. And maybe just for reference, I do have a 36 megahertz oscillator. So I'm running 16 into the board. The processor would then be running at 8. So I'm just running an 8 megahertz processor at this point. And everything's working as far as SPI, and it's all going through this VIA minus the RTC communication. But if I take this and just maybe drop down the speed of the system, I'm just going to go with 1/4 of the speed, so 2 megahertz. Obviously, it takes longer to go through the power on self-test. The beep sound, if you can hear that, will be a lower sound. But when I go through and do that, I'm getting appropriate date or time and temperature. That seems to all be working, and everything is passing. If I go at half speed, that'd be 4 megahertz. I can see I now have problems. So there's something between 2 and 4 megahertz that in my communication with this RTC, real-time clock, something has changed in my system. So I'll just have to do some troubleshooting. I'll connect up my SPI debugger for that, and I'm guessing it's just going to be timing related, but more to come. I don't know what the answer is going to be there. I'm going to go back to full speed here, 8 megahertz processor. Other things that I've done, or maybe should call out, in the last video I did mention that the values on these LED bar graphs, the bottom 3 here for the address, were backwards within each 8. At this point that isn't a concern because I've disabled those anyways, because they're not doing a lot of good. And these probably aren't doing a whole lot of good at this point either, just because of the speed. On my VIA, I forgot to place a couple decoupling capacitors by it, so I just ended up soldering those to the bottom. I grabbed the power pin and soldered on 2 capacitors and then run that to the nearest ground, 0.1 and a 0.01 microfarad. So that would be this bullet right here. Now on the PS2 keyboard circuit, I did modify that, and you'll see this extra little basically a board here, solderable board. A couple things I did. There's a resistor in the circuit that normally I had as a 33K resistor, and with that resistor, that helps control some of the timing when it comes to the interrupt. Now on this keyboard here, that 33K was perfect and it worked well, but I wanted to go to a smaller keyboard just because this Microsoft keyboard is pretty big and bulky. So I found that 33K wasn't quite right, and I didn't want to try to just put in a resistor value and have it locked into a keyboard or optimized for a specific keyboard. So I put in a potentiometer, a little trim pot there, so that I can come in here and work with this. So here I can say hello world. You notice right away I got a question mark, so that's something I've got to work on. When I first turn on this system with this keyboard, a couple of things with it. It expects an acknowledgement from the host before it's actually going to function. And what I've done there is put in a little circuit that kind of does that auto reset of the keyboard. So power comes on and it auto resets. And in my blog, you'll notice I reference George Foot's design. He goes by gfoot360 on Reddit, I believe, but I have a link there if you want to take a look at what that is. Simple little circuit though, quite handy, and it seems to be working well, so that when I turn on the system, it automatically just resets the keyboard or gives that acknowledgement to the keyboard so that I can start typing. And right now I have the potentiometer pretty close to what it needs to be for this keyboard. But like there I hit escape and I got a J, so that's telling me something's not quite perfect yet. So I'll keep working on that. I can type pretty fast, but there, that's coming fine, coming through fine. So I'll just have to play with that and see where I'm catching incorrect scan codes coming from the keyboard, and whether it is the keyboard or the circuit. More than likely, one of the challenges, it's still on my to-do list, I have to update my assembly code so that the keyboard processing doesn't happen in the interrupt. Instead, all I want to do is fetch the scan code and put it into basically an array or a buffer so that I can process those in my normal loop. I've not done that yet, so that could be part of my challenge here too. I need to get that updated. So that is what the circuit is. It gives me my trim pot, gives me a couple of ICs that allow me to do this auto reset of this this smaller keyboard, which I'm going to use moving forward. This next bullet, at one point I had moved the VIA chip select on my PSOC to a different pin. It was on a pin, and some of these pins have capacitors attached to them on the PSOC. And those capacitors cause a world of problems. So I need to make sure all my outputs are on pins that don't have those capacitors. And I had moved it in the PSOC, and on my old breadboard I must have moved the wire, but I did not update the schematic. So this PCB was using the wrong pin to come over to my control latch. So I just basically pulled the pin up on this IC and ran that other proper pin over, just using this header that I had put around that PSOC. So that worked well. Also over here on the Nano, I had on the schematic the pin for one of the I2C signals on the wrong, marked incorrectly. No changes needed to the PCB. I just had to move a wire here, but as I was plugging things in, I noticed that that was incorrect, so I have corrected that. And I think that's about it. So if I just kind of walk through what's here, I've got my reset card. Again, I've got to figure out why that hold down isn't working. properly, so that'll be one thing I have to do. And we've got my LCD output, we have my PSOC, math coprocessor interrupt, got the processor itself, of course. I have a couple of PPIs, one up here, one down here. This one up here is running both the speaker, and then this one is also running that LCD. This one down here is handling the keyboard input. I have my RAM, I have my ROM sitting in these nice stiff sockets, which have been very nice to have those put in. I have both the Arduinos. I desoldered all of the standard, well, I take that back. On the Mega, I desoldered all of the standard headers, pulled out what was there because they normally face up with a female connector. I took that out, put in male connectors facing down, and then in the PCB, I put female connectors facing up. So I can just pull this entire Arduino out just by pulling it up and out, or swap it out if I wanted to. So that's basically socketed, if you want to think of it that way. I did the same thing with the Nano. It's in a socket there. Here's my VIA. I have pins here so that I can connect my other, whatever I come up with in the future for SPI devices. So my MOSI, my MISO, my clock, I have 4 pins available for each of those. And then for all the different chip selects, I have a pair of pins that I can use. SD cards mounted here. I mounted the little OLED screen just simply on some little stands and just glued that to the top of the PCB. My RTC is just simply a little double-sided tape. I just stuck it to the top of that little USB connector on my Arduino, which is fine. The RTC and this OLED, those are things I did after I had ordered this PCB. So in a future version, those will just be part of the PCB design. I've got my 2 ISA slots ready to go, and that does mean I can get over to my video card and get this connected in here sometime pretty soon. That'll probably be something I'll get to maybe in the next 2 or 3 weeks. I'll try to get over to this card and see if I can't do something with it. Prior to that, I would like to clean up this SPI for the RTC and also figure out why this auto reset's not working. Because that's going to annoy me every time I power up to have to press that button. That's all that's coming to mind for now. I would say generally things are working as they should. The one thing I did on my breadboard version is I did put internal data bus pull-up resistors. I don't have that on this PCB, so we'll see at what point does the math coprocessor have issues with speed. But right now I'm running again 36 here. This oscillator would give me my 8 megahertz. I'm actually running 9 megahertz on the processor right now, and everything's passing. The only thing that's not working is the real-time clock. But multiple SPI devices are run off this VIA, and they're all working except for the real-time clock, which tells me it's just timing with the real-time clock more than likely. This is a 9 megahertz processor clock, and that all is running well minus the RTC. So I think that's what I'm going to try to dial in a little bit, see if I can get this 9 megahertz dialed in, or 8, one or the other, and call that good. So that's where I'm at. I've got some minor things to clean up, but nothing that is too concerning, quite honestly. So I think this was good progress to get the rest of this built out. Oh, and as a side note, I did test the logging at a slower clock speed coming out of the Arduino Mega, and that was all looking like it was all logging properly. So I don't have any concerns with that. Good enough for now. Thanks for watching.